Hello friends, today we will configure VRRP on the topology as shown in the video. We have these three tasks. First is configure VRRP on the given topology. Second is core 1 and core 2 should be backup of each other as well as they should be capable of load sharing. Means both the switches should work equally, though it is possible for us to configure as core 1 as a master switch and core 2 as a backup switch, but to uh, we want both of these switches to be the backup of each other as they should work uh, equally. If we have suppose four VLANs, two of the VLANs should uh, core 1 should be the master for two of the VLANs and core 2 should be the master of remaining two VLANs. Moreover, we will configure STP on all of the switches, and we will make the core 1 as a root switch for half of the VLANs and core 2 as the root switch for remaining half of the VLANs. So guys, let's start our configuration here. We will configure uh, four VLANs, 10, 20, 30 and 40. We will make core 1 as a master switch for VLAN 10 and 20 and core 2 as a master switch of VLAN 30 and 40. So guys, let's start with our access switch 1. Control C, system view, host name, access switch 1. Okay guys, we will create VLANs in this switch now. VLAN 10, 20, 30 and 40. Only two networks, means VLAN 10 and 20, will be active on this switch. First five ports of VLAN 10, first five port of this switch will be assigned to VLAN 10, and the second five ports will be assigned to VLAN 20. Okay, guys, interface range. First five ports. Port, link type, access, port, access VLAN 10. Interface range, gigabit 1 to gigabit, sorry, 6 to 10. Port, link type, access, port, access VLAN 20. Interface range, gigabit 47 to gigabit 48, which will be our trunk ports. First trunk is connected to the core switch and second trunk is connected to the access switch 2. port, link type, trunk, port trunk, mm, permit, VLAN 10, 20, 30, and 40. STP mode pvst, STP. Okay, it's enable now. Save. Now we will configure our access switch to system view, host name, access switch to VLAN 10, 20, 30, and 40. Interface range gigabit 5. We will configure this switch for two VLANs 30 and 40. First 5 ports for VLAN 30. Port link type access. Port access VLAN 30. Second 5 ports for VLAN 40. Interface gigabit 6 to gigabit interface range 6 to gigabit. Port link type S. Port access VLAN 20. Interface range gigabit 47 to gigabit 48. Port link type trunk. Port trunk permit VLAN 10, 20, 30, and 40. STP mode pvst. Save. Okay. Now we will configure our switch 3. Control C. System view. Host name. VLAN 10, 20, 30, and 40. Interface range gigabit 1 to gigabit 5. First 5 ports for VLAN 30. Port link type access. Port access VLAN 30. Interface range gigabit 6 to gigabit. Port link type access. Port access VLAN 40. Interface range gigabit 47 to gigabit 48. Port link type trunk. Port trunk permit VLAN STP mode pvst. Save. Okay, now our switch 4. Control C. System view. Host name. Access switch for VLAN 10, 20, 30, sorry, 30 and 40. I think we have to create separately. Okay, first 5 ports for VLAN 10. Then gigabit, port access VLAN 10, port link type access, port access VLAN 10. Okay, interface range gigabit 6 to gigabit, port link type access, port access VLAN 20. Quit STP mode pvst. Okay, save. Now we will configure our core 1. Control C, system view, host name, core 1. And now VLAN 10, VLAN 20, VLAN 30, VLAN 40. Now we will configure our VLAN interfaces on this switch. Interface VLAN interface 10, IP address 192.168.10.254.255.255. And now we will configure our VRRP ID 1, virtual IP 192.168.10.1, VRRP VRID 1, preempt mode, VRRP VRID 1, priority. By default its priority is 100, but we want our VLAN 10 and 20 as yeah, to be prioritized on this switch. Means core 1 will be master for VLAN 10 and 20. Interface VLAN interface 20, IP address 192.168.20.254.255.255. Sorry. VRRP VRID 1, virtual IP 192.168.20.1, VRRP VRID 1, and preempt mode VRRP VRID 1 and priority 101. Interface VLAN interface 30, IP address 192.168.30.255.255.255.0, VRRP VRID 1, virtual IP 192.168.30.1, preempt mode. We don't want VLAN 30 and VLAN 40 to be prioritized on this switch, as we want these two VLANs and to be prioritized on core 2. Interface VLAN interface OT IP address 192.168.40.255.255.0 VRRP VRID 1 Virtual IP 192.168.40.1 VRRP VRID 1 preempt mode interface range gigabit. Let me check. 48, 47, 46, 46 to gigabit, 48 port link type trunk, port trunk permit VLAN 10, 20, 30 and 40. STP mode pvst STP VLAN 1 priority 0. We want core 1 to be the master for half of the VLANs and core 2 be the master for remaining half of the VLAN. STP VLAN 10 priority 0. STP VLAN 20 priority 0. STP VLAN 30 priority 4096 and same will be for VLAN 40. Now we will configure our go-to. Control C, system view, host name, core 2, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Interface VLAN 10, IP address 192.168.10.254.255. Sorry, on this switch we will configure a separate VLAN interface ID. VRRP VRID 1 virtual IP will be 192.168.10.1. This IP will be same. VRRP VRID 1 preempt mode. We don't want to prioritize this VLAN on core 2. Interface VLAN interface 20 IP address 192.168.20.253.255.255 VRRP VRID 1 and virtual IP 192.168.20.1 VRRP VRID 1 and preempt mode. Interface VLAN interface 30 IP address 192.168.30.253.255.255 VRRP VRID 1 virtual IP 192.168.30.1 VRRP VR ID 1 preempt mode, and now we will prioritize this VLAN on go to priority. STP mode pvst. Now STP VLAN 1 priority 4096 STP for VLAN 30 and 40. This switch will be acting as a you can say the root switch. Okay, interface VLAN interface 40. IP address will be 192.168.40.253.255. Okay, now VRRP VRID 1 virtual IP 192.840.1 VRRP VRID 1 preempt mode VRRP VRID 1 priority 101. Let me save my configuration. Save. Okay, now I will assign statically IP addresses to my end users. Configure enable static IP 192.168.10.101.255.255 192.168 and 10.1 192.168 10 sorry 20.11 192.168 20.1 192.168 30.11 192.16255.255 apply 192.168 40.11 40.1 192.168 30.102 168 30.1 192.168.40.102.40.1 192.168.10.102.10.1 192.168.20.102 display VRRP. Okay, let me see the configuration. Display current configuration. Here we have STP on VLAN with priority 0. This PV global enable 10. Okay, one thing is missing in core 2 interface range gigabit 46 to gigabit 48 port link type trunk port trunk permit VLAN 10, 20, 30 and 40. Here you can see that VRRP is now fully operational. Let me show you. Display VRRP. You can see on this switch VLAN 30 and 40, it's master switch, and on this switch it's master for VLAN 10 and 20. Okay, let me show you one thing. Let me check whether it's It automatically shifts the traffic from core 1 to core 2 for the VLANs 10 and 20. If the core 1 goes down or all the ports of core 1 goes down, interface range gigabit 46 to gigabit 8 shutdown. There you can see that VLAN interface 10 change from backup to master. Similarly, VLAN interface 20 change from backup to master. Let me show you all the VLANs are for all the VLAN. This core 2 is acting as a master switch. Let me restore core 1. You can see VLAN 10 change from master to backup. There you can see. Similarly on core 1 display VRRP. So guys, this is what we wanted to achieve in this lab. I hope you have understood the main idea of the lab. If you want to see more videos regarding this VRRP or redundant routing protocol, you can see my other VLAN, other videos uh, which I configured for the Cisco and packet tracer. I will give the links of those two videos in description as well. I hope you will get a better idea about this lab. Thank you guys.